While studying organic chemistry, we deal with various reaction mechanisms in hydrocarbon, haloalkanes and haloarenes, alcohol, phenol and ethers, aldehyde, ketones and carboxylic acid, amines, and also biomolecules. Let's discuss all these in one video and covering all the reactions for JEE mains, JEE Advanced and Neet. First of all, we all know that we will be going to know about addition, elimination, substitution, SN1, SN2 reactions. So number 1 is Voigt's reaction, in which RR formation take place and the reagent is Na dry Et2O. There is also Fittig reaction where AR aromatic one is used, aryl is used, and in Ullmann कॉपर इज़ यूज, इन फ्रैंकलैंड जेडन इज़ यूज. यू को टेढ़ा करेंगे तो सी हो जाएगा, ऐसे याद रखते हैं. एंड देयर इज ऑल्सो वन रिएक्शन कॉल्ड वर्क्स फिटिक रिएक्शन, in which Rylex and Rx react in the presence of Na and delta and we get RAR. Now reaction with metal and acid. Metal H plus देता है, so Rx बन जाएगा in the presence of metal and acid RH. यहीं से कॉन्सेप्ट आता है ग्रिग्नार्ड रिएजेंट एंड गिलमैन रिएजेंट का भी. ग्रिग्नार्ड इज RMgX and R2CuLi is Gilman reagent. कोरेहाउस सिंथेसिस में भी RR बनता है. दिस इज पिनाकोल फॉर्मेशन. यहाँ डबल बॉन्ड हटेगा और ये दोनों ही लग जाएंगे. दिस इज एसाइलोसिन कंडेंसेशन, नॉट सो इम्पॉर्टेंट. Now the important one, that is Kolbe electrolysis. In this CO2, H2 and NaOH with RR formation take place. If I talk of photohalogenation, then it is very important reaction in the presence of RH plus X2 and UV rays or H nu or sunlight. We get formation of Rx plus HX. Order of reaction of X2 is F2 greater than Cl2, then Br2, then I2. Remember the fact that fluorination is exothermic and explosive. Iodination is less reactive and reversible. Whereas these two are too much important, that chlorination is more reactive. Like the ratio is 1 is to 3.8 is to 4.5, and bromination is more selective, like the ratio is 1 is to 80 is to 1600. Now N-bromosuccinamide, that is NBS reaction, mainly for allylic and benzylic, यानी डबल बॉन्ड के बाजू वाला जो कार्बन है उस पर लगता है. जैसे हम यहाँ पे देख सकते हैं, डबल बॉन्ड के बाजू वाले पे लग गया Br, दैट इज ब्रोमिनेट, वो NBS. So there are various type of reactions like addition, elimination, substitution and rearrangement. If in a reaction carbocation formation take place, then it means a radical has formed. Now it will get stabilized by rearrangement. And we may also observe ring expansion. So this is hydrohalogenation. In this we can observe the double bond with the reaction of HX and CCl4. We get CH3 single bond CH2 and attached with X. This happens when there is reaction with XX. The same question can be given in different ways like this. In the case of hydroboration oxidation, anti-Markovnikov rule is followed and the reagent is BH3 THF H2O2 NaOH. In Kucherov reaction, 1% HgSO4 and dilute H2SO4 is used. In Kharas effect, or we can say peroxide effect, HBrCCl4 like Markovnikov addition and carbocation formation, and HBrPHCOO2H is anti-Markovnikov reaction, where the Markovnikov में जहाँ H कम होते हैं वहाँ पे जाके हमारा लग जाता है. These two are very important reaction in which phenol reaction with Zn and delta give benzene, and phenol reaction with K2Cr2O7 give benzequinone. These are glucose reaction. When glucose reaction take place with AC2O, then this formation take place which confirm 5OH, and with when red PHI and hexane which confirm the linear carbon chain, and when NH2OH then confirm aldehyde and ketone. H2 nickel we get disorbitol. Br2H2O with that digluconic acid, and HNO3 we get saccharic acid. When beta D galactose and beta D glucose get bonded by glycosidic bond, then lactose formation take place. When alpha D glucose and alpha D glucose glycosidic bond formation takes place, then maltose forms. And if I talk of sucrose, then it is between glucose and fructose. This is the structure of fructose. This is beta form and this is alpha form. If I talk of amylose and amylopectin, then amylose is a linear chain that is water soluble, and amylopectin is branched one that is water insoluble. Cellulose contain beta D glucose. Also should have idea about these structures. Remember that all are primary amino acid except proline. Proline structure is like this, and pH value are ARG, L, then H. These are basic amino acids, and acidic are aspartic acid and glutamic acid. Remember that A is with double bond with T, and G is with triple bond with C. A double bond T, G triple bond C. This is all a bonding between bases. Discussing about DNA, RNA, like this. This is the structure of hydrogen, and this is oxygen. Only we can see the difference, like this is like in fructose one, and this is like this. This is Gabriel pethylamine synthesis. This is phthalic acid, and this is pethylamide. If we have to discuss its stability, then SN2 occurrence is checked. This is the process. In Hoffman bromamide, primary amine react with NaOH Br2 to give primary amine. When the reaction is with H2PDBASO4, then it is Rosenmund reaction. When CrO2Cl2, Itard reaction. When and all these reactions are. When there is COHCl, AlCl, 3CuCl, then it is Gitterman-Koch reaction. This is Hell-Vojard-Janicki reaction, HVZ reaction. In this, alpha halogenation of carboxylic acid take place, in the presence of red phosphorus and water. These are more reactions. Canojaro occurs when aldehyde without alpha halogens. These are reaction with chloroform. This is Kolbe reaction. And this is cumene hydroperoxide rearrangement. Now Riemann-Tiemann reaction with chloroform NaOH, and there is also abnormal Riemann-Tiemann reaction. This is carbylamine reaction, and we should also know about carbene. There are two types, singlet carbene and triplet carbene. This is singlet and this is triplet. When there is reduction with red PHI or HI delta, then it is called Serve-Safi reagent. It removes all the oxygen. Now Clemenson and Wolff-Kissner, these are two important reactions. In Clemenson, ZnHg and HCl is the reagent, and an acidic medium is used, whereas in Wolff-Kissner basic medium is used and NH2 is the reagent. These are metallic hydride, double H only react once, and this is B2H6, this is LiAlH4, and this is NaBH4. LAH is non-selective and double H is very selective. Polar aprotic LAH, polar aprotic solvent is used, all carbonyl and nitrogen groups. This is Williamson-Ether reaction, RO plus RX, the ROR. When there is NAI isotone or Zn-das delta, dehalogenation take place, in which elimination when there is double bond formation, then it is elimination reaction. FOH, OR and R3 and SR3 plus are poor leaving group. TBUO minus, and these all are strong bases. Alcoholic KOH E2 done mostly, and aqueous favor SN2. If I talk of summary, then if there is a strong base, then it will only see stability of delta minus. If there is moderate base like alcoholic KOH, then it will see is there poor leaving group like OH and F, then it will show stability of delta minus. If there is moderate or good leaving group, then it will see stability of alkene. If I talk of elimination reaction, then double bond formation take place. There may be two laws about Jetsev and Hoffman. Jetsev may more substituted alkene and Hoffman may less substituted alkene. So this is E1 unimolecular elimination reaction, and this is E2 biomolecular elimination reaction. This is Darjan reaction when there is reaction with SOCl2. This is reaction with PCl3, PCl5. There are also reaction with ether, and here is the reaction with alcohol with HX. These are two important reaction with AG. We have Schwarz reaction, and this is Finkelstein reaction, very important. NaI and acetone is used as a reagent. Now Let's take idea about SN1 SN2 reaction. SN1 means unimolecular and SN2 means bimolecular. In SN1 reaction, Ri, and this is the reactivity order of halogens, same in both. SN1 is first order and SN2 is second order. In SN1 there is carbocation formation. Also remember that SN2 में अम्ब्रेला इन्वर्जन होता है और ये सारी इम्पॉर्टेंट चीज़ें हैं. और SN1 में हमें कार्बोकेटायन फॉर्मेशन देखने को मिलता है और रेसमिक मिक्सचर बनता है. There are various other reactions like SN2AR, coupling reaction, and finally the important one, that is SN2AR. These are Sandmeyer and this is Gutterman reaction. Gutterman Koch is different thing. This is Gutterman reaction in which copper is lonely. This BDC formation, this N2 plus Cl minus by NaNO2 के साथ रिएक्शन कराते हैं जब ये बनता है एट 0 से 5 डिग्री सेल्सियस. इसे डायजोटाइजेशन कहते हैं. कुछ डिफरेंट रिएक्शन. This is Friedel-Crafts acylation. This is Friedel-Crafts alkylation. This is halogenation of aniline. This is halogenation. Then all the process like nitration, which can be given like these reagents. There is sulfonation, nitration, halogenation, alkylation and acylation. For sulfonation, oleum, that is H2S2O7, can also be given. Now let's talk about simple things like plus I series, that is CH negative charge, then 3 degree, 1 degree, 2 degree, then CT3, CD3 and CH3. For negative charge we have positive, then NO2CN COH, then X, then OROH, then NH2 triple bond and benzene and double bond. एरोमेटिक के लिए 4n+2 पाई इलेक्ट्रॉन, एंटी एरोमेटिक के लिए साइक्लिक करंट एंड 4n इलेक्ट्रॉन. इलेक्ट्रॉन डोनेटिंग ग्रुप होता है +R +M. ऑर्थो पैरा डायरेक्टिंग होता है. इलेक्ट्रॉन विड्रॉइंग ग्रुप होता है -R -M. मीटर डायरेक्टिंग होता है. इसमें वीकेंट और बाइटल आ सकता है. एंड रॉबिन हुड ये नेट -I दिखाता है. Cl Br In डबल बॉन्ड O, ये सब इसमें आते हैं. बट अबाउट हैलोजन्स, हैलोजन मोस्टली ऑर्थो पैरा होते हैं लेकिन डीएक्टिवेटिंग होते हैं. आपको एक समरी चार्ट हेयर. देयर आर ऑल्सो रिएक्शंस ऑफ हाइड्रोकार्बन. soda lime decarboxylation NaOH reaction. This is Birch reduction reaction with Na liquid NH3. It get reduction to alkyne to a trans alkene. We can see here. When there is reaction with hot KMnO4, then aldehyde can convert to RCOH and ketone to trimerize, then oxidative ozonylysis, alcohol to RCOH, and same for benzylic H. If benzylic carbon has H present or double bond, triple bond present, then it will convert to benzoic acid. Now finally ozonolysis. If there is reaction with then glyoxal formation take place, that is CHO. Ozonolysis is of two type, oxidative and reductive. Now let's also talk about attacking reagents that are electrophile, nucleophile, and also let's talk about solvent. Solvent are of polar, non-polar like CCl4 and CS2. पोलर में प्रोटिक एंड एप्रोटिक. प्रोटिक में इलेक्ट्रोनेगेटिव के साथ H हो, जैसे H2O, ROH, RCOH. एप्रोटिक में इलेक्ट्रोनेगेटिव के साथ H ना हो, जैसे कि ये ET2O एक्सेट्रा. इलेक्ट्रोफाइल पॉजिटिव चार्ज ये इनकम्प्लीट ऑक्टेट होता है, और इलेक्ट्रोफाइल में नेगेटिव चार्ज ये कंप्लीट ऑक्टेट होता है. Let's also talk about enantiomers, diastereomers, homomers and meso, and also racemic mixture. Racemic mixture तो accumular mixture of enantiomer, और meso optically inactive compound with at least 2 chiral center. chiral center मतलब चारों तरफ डिफरेंट चीज़ें लगी हैं. होमोमर की बात करें तो सेम फिजिकल प्रॉपर्टीज़ लेकिन सेपरेट नहीं हो सकते बाय फ्रैक्शनल डिस्टिलेशन या क्रिस्टलाइजेशन. और डायस्टीरोमर्स जो नॉन मिरर इमेजेस होती हैं, एक दूसरे की सुपर इम्पॉसिबल नहीं होती है, डिफरेंट फिजिकल प्रॉपर्टी, और ये सेपरेट हो जाती हैं. और बात करें एनेंसियोमर की तो ये ऑप्टिकली एक्टिव कंपाउंड की मिरर इमेजेस होती हैं, नॉन सुपर इम्पॉसिबल होती हैं, सेम फिजिकल प्रॉपर्टीज़ होती हैं और सेपरेट नहीं हो सकते. अंतर जो आता है एनेंसियोमर में वो यही है, ऑप्टिकल रोटेशन. राइट साइड के लिए D होता है, लेफ़्ट साइड के लिए L, सेम साइड के लिए E होता है, अपोजिट साइड के लिए T. लेट्स ऑल्सो टॉक अबाउट गॉच एंड एंटी. गॉच में जो बल्किएस्ट ग्रुप जो होते हैं वो पास आ जाते हैं, और जब बल्किएस्ट ग्रुप दूर हो जाते हैं तो एंटी. ऑप्टिकली एक्टिव कंपाउंड वो होता है जो रोटेट करता है PPL को, और इसे कायरल कंपाउंड भी बोलते हैं या रिजॉल्वेबल कंपाउंड भी बोलते हैं. इसमें ना ही पॉस होता है, ना कॉस होता है, ना AAOS होता है. मिरर इमेजेस ऑप्टिकली एक्टिव कंपाउंड की डिफरेंट होती हैं. अगर बात करें नोमेनक्लेचर की तो FMLA से रूल होता है, और फिर कॉमन नेमिंग आ जाती है. आइसो मतलब 1 पे 2, लाइक दिस. हमारे पास डिफरेंट होते हैं, लाइक विनाइल, अलाइल एक्सेट्रा. थैंक यू. वी हैव कवर्ड ऑल द टॉपिक्स फॉर योर कॉम्पिटिटिव एग्जामिनेशन in organic chemistry. Like, share and subscribe for more.